Yeah, oh yeah, it just picked you up. Oh yeah. Oh yeah. Yo. All right, let's talk angles today because that's a trig thing. Okay. So let's talk about our fun little angles. So angles. Angles have three parts to them that you probably maybe knew about. Okay. I know you know about one of the parts. Okay. And that's this wonderful part right here called the vertex. Okay. Angles also have something called an initial side. It's where the angle starts. The angle ends at what is called the terminal side. Okay. So we start at the initial side, we go all the way through the terminal side. And the rotation that we have to take to get from the initial side to the terminal side is called the measure of the angle. From initial So the measure of our angle is the amount of rotation that it takes to go from our initial side to our terminal side. Now, we can rotate one of two ways. I can rotate like this, or I can rotate like this, right? Or, to make it universal for everyone, and I know that you guys are of a digital age, but there used to be this thing called analog clocks. There's an example of one right up there. Okay? Clockwise and counterclockwise. Okay? Clockwise would be going around, if we think about it on the unit circle, clockwise would be going around in this motion. Counterclockwise would be going around in this motion. So if we refer back to the unit circle once again, the positive angle or a positive angle has counterclockwise rotation. I forgot the N in counter. Bad arrow. Counterclockwise rotation gives me positive angles. Negative angles have clockwise rotation. Now, angles can be all over the place, right? I'm making angles with my arms right now. Okay? There could be here, they could be there, they could be over here, they could be down here, they could be over there, wherever, right? Okay? So in order to bring some order to this process, bless you, we have what is called the standard position of an angle. The standard position has two conditions in it. The first condition is that the vertex is at the origin. So our first condition is that the vertex is at the origin. Second condition is that the initial side is on the positive x-axis. Okay. When in doubt, think of the unit circle. The unit circle is centered at the origin, and the initial side for all of our angles is the zero angle, which is straight out to the right along the positive x-axis. From there, all of our angles are measured. So if I have this angle right here, in the positive direction, which is kind of where my hand is holding this roll of contact paper, in the positive direction, the angle is 45 degrees. In the negative direction, the angle is negative 315 degrees. Okay. If I go over her, my positive angle is now 5 pi over 6, or 150 degrees. My negative angle is negative 7 pi over 6, or negative 210 degrees. Okay. So an angle can have multiple angle measures at it. Okay? And we call that coterminal angles. Coterminal angles are angles in standard position with the same terminal side but different measures. So, for instance, 30 degrees. Okay. That's my initial angle. My angle here is 30 degrees. Let's find at least 4 coterminal angles to go along with 30 degrees. One of them is negative 330 degrees. I just rotated the opposite way, right to the same spot. Okay. Give me another one. Give me another coterminal angle. or an angle that would have the same blue terminal side. Okay. 390 degrees? Do we agree with 390 degrees? $390, I would start here. I would go all the way around and then end up at the same spot. Give me another one. Negative 690 degrees? I would agree with negative 690 degrees. So I would start here, and I would go all the way around. That's negative 360, and then I've got to go all the way around negative 330 more, and end up at negative 690 degrees. Give me another one. Another positive one. 750 degrees. What's the difference between the three positive angles and the difference between the two negative angles? 360 degrees. A lap around the circle is 360 degrees. So the difference between all coterminal angles is 360 degrees. So really the difference between all 5 of those angles is 360 degrees. Okay? What I would like you to do now is I would like you to find me coterminal angles, one positive and one negative, for those two angles. I got negative 150 degrees being down here. Which would give me, on the negative side, I would have negative 510 degrees, negative 870 degrees, negative 1230 degrees, negative 1590 degrees, etc., all of those. On the positive side, I'd have 210 degrees, 570 degrees, 930 degrees. Agree? Yeah. 2 pi over 3, I have that up here. Other positive angles to go along with that, I would have 8 pi over 3, 14 pi over 3, 20 pi over 3. Negatively, I would have negative 6 pi over 3. Come on now. Whoa. funkiness is going on, all abounding around. Where'd my thing go now? Oops, not negative 6 pi over 3. Tap the brakes, Linsmeyer. Negative 4 pi over 3. Got all flustered with the funkiness of the board. Negative 10 pi over 3. Negative 16 pi over 3. Agree? On the left one, we were adding and subtracting 360 degrees. What am I adding and subtracting on the right one? 2 pi. But I'm not thinking about it as 2 pi. I'm thinking about it as 6 pi over 3. Because that's 2 pi. Okay. If I were in the fourths, I would think of it as 8 pi over 4. If I was in the sixth, I would think of it as 12 pi over 6. If I was in the halves, I would think about it as 4 pi over 2. Okay. Fantastic. Let's find a theta here. Uh-oh, finding theta. That means we got to think back to when we were trees. Right? If I think back to gee, I'm a tree, okay, and I find theta, what do I have to use in order to find an angle? What do we use? It's the inverse of the SOHCAHTOAs, yeah. The inverse of those trig functions. Okay? So if I'm way down here at negative 3 comma negative 2, this angle here is my theta. The downfall is that in order to use SOHCAHTOA, I've got to shorten. Oops, that's a bad triangle. We'll reset that. I've got to shorten up my angle, and I would say like this is angle T here. This is negative 3 there. That's negative 2 there. Okay? So the tangent here of T is equal to negative 2 over negative 3. Opposite over adjacent. But I want to find T, so T is going to be the inverse tangent of that fraction. Well, somebody with a calculadora, what is the inverse tangent of negative 2 divided by negative 3? What's the problem with T in relationship to theta? Mark, what do you got?
C plus 180 equals theta.
Are we sure? Because theta's got to be between 180 and 270 degrees, right? And because theta's in the third quadrant. But we found it, so we can't do it. Okay? So what we actually found, and Mark is correct when he says that, what we actually found is something called the reference angle. Okay? Reference angles are acute angles formed by the terminal side of theta and the horizontal axis, or the x-axis. Okay? Theta prime, you will hear us say this a lot, the reference angle is always off the horizontal. We will say that numerous times because for some odd reason, when we say it at the start of finding reference angles, which we just did, you forget and you make your reference angles off the vertical axes. Okay? Reference angles always come off the horizontal axes. Okay? So, since we have 4 quadrants, we have 4 possible reference angles. First off is if we are in quadrant number 1. Quadrant number 1 is nice because quadrant number 1 is already the acute angles, so theta is equal to its reference angle in quadrant number 1. In quadrant number 2, theta would be here. Theta prime, my reference angle, would be there. So in quadrant number 2, theta is equal to 180 degrees minus my reference angle. Or it's equal to pi minus my reference angle, depending upon if I'm in degrees or radians. If I am in quadrant number 3, there is my theta. My reference angle would be there. So theta, oops, I almost put theta prime. Theta is equal to 180 degrees plus my reference angle, or pi plus my reference angle. If I am in quadrant number 4, there is my theta, there is my reference angle. So theta is equal to 360 degrees minus my reference angle, or 2 pi minus my reference angle. Always trying to get back to the horizontal. Either 180 or 360 is what you're trying to get to. And that angle to get to the horizontal is your reference angle. So when it says find theta prime, or find my reference angle for these 3 angles, 125 degrees would be up in quadrant number 2. Which means my reference angle would be off the horizontal, and it'd be located right there. So what is my reference angle? Well, I'm thinking I gotta get to the horizontal. So I either gotta get to 180 or I gotta get to 360. To get to 180, I would add 55 degrees. So my reference angle is 55 degrees. 220 degrees is down here. My reference angle is there. So 220 to get back to my closest horizontal is get back to 180. So I would have to have a reference angle here of 40 degrees. Nope, you got to get back to the horizontal. Reference angles have to be acute. So if I added 140 degrees to that to get to 360, right? What did I do wrong? Right, but that it's 180 plus theta prime plus the reference angle. Yeah, all of those way down here were all thetas equaling, not what the reference angle was. Okay? Because the reason I wrote them this way is because you're gonna find the reference angle using trig. Okay? So then, depending on what quadrant you're going to utilize your reference angle from there. Oops, went too far. Double tapped. Okay? 310 degrees is down here. My reference angle theta prime is there. So my reference angle here would be 50 degrees. Okay. Now, the nice thing, as we're running out of time here, the nice thing about the reference angle and the actual angle is that they all have the exact same trig values. The sine of 125 degrees is the sine of 55 degrees. The cosine of 220 degrees is the cosine of 40 degrees. The tangent of 310 degrees is the same as the tangent of 50 degrees. Okay? Great spot to stop. Thanks for playing along.